Okay, this is the solution for question 1. Here you are shown a figure of a series resistor circuit with a 12 volt supply and two resistors R1 and R2 at 24 and 36 ohms. You're asked to determine V1, that was the voltage across R1, so that would be this, VR1. You're asked to determine the voltage across VR1, as indicated here, and also the voltage across VR2. So, how do we do that? Well, effectively what we have here is a 12 volt supply going to ground via two resistors. So part of that 12 volt supply is going to be dropped across R1 and R2. What we have here is a voltage divider circuit or a potential divider circuit. So while I'm doing the calculations on this, if we want to find the voltage across R1, so we're looking at the voltage across R1, well, what we do is we take the voltage supply, Vs, and we multiply that by the voltage across the resistor we're interested in this case it's R1, and that resistance is divided by the total resistance in the branch, which is R1 plus R2. So we can plug in those values and you get 12 volts, and it's by 24 ohms divided by R1 plus R2, so that gives you 60 ohms. When you plug those values into your calculator, you'll get a VR1 of 4.8 volts. Now to find the voltage drop across R2, we can do the exact same, take the exact same approach. So VR2 is your voltage supply. This time we're interested in the voltage across, potential drop across R2, and the total resistance in the series network is R1 plus R2. You can plug in those values, 12 volts, and here we have 36 ohms divided by R1 plus R2, which is 60 ohms. And you plug those values into the calculator, you'll get 7.2 volts. So Vs, the voltage supply, just to get a little bit of background, is equal to VR1 plus VR2. And if we add those together, we can see it is 4.8 volts plus 7.2 volts. That equals your 12 volt supply. Now, we didn't actually have to use the potential divider to calculate VR2 once we had VR1, because we know that Vs, voltage supply, has to be equal to VR1 plus VR2. And we knew that this was 12 volts. We just calculated VR1 to be 4.8 volts. So we know that VR2 added to that 4.8 volts. So we could have calculated VR2 to be equal to your Vs minus VR1, which is your 12 volts minus your VR1, which is 4.8 volts. And that gives you your 7.2 volts. So you could have taken either approach to calculate VR2.